Thank you so much for having me, and thank you for the opportunity. I would also like to thank all the thinkers that came before us, and all this legacy that was left, sometimes encoded in these different kind of operative languages, but there's so much richness in all the materials, in all the literature, that I'm always like in awe. Um, and and furthermore, I'm also incredibly thankful to all the kind words and support throughout this project. Um, and so with this proposal, that we have uh, patterns that ingress and that these patterns are mathematics, I would like to let it be very clear that I don't mean mathematical formalization. I think it was Benjamin Lyons, he had this specific definition for his proposal of what mathematics is. And although I'm still writing upon what it seems that mathematics is, there's so many good writings on it already in terms of this narrative and this construction that is done over time historically. And so this presentation, or the scope of this project, is not about that. It is about if accepting completely the premise that we have patterns that ingress, and thus to explore it, for me, this is a transport problem. In the 1500s, Jordan Bruno had this beautiful insight, that it is not possible that a body glides towards infinity or downwards, evidently, as moving it verifies in it all its movements or transmutations. As in generation does not look how to do what it cannot be done or achieve, and the same goes for spatial movement that does not look for space out of reach. And I guess the gist is that given that mathematical patterns or these patterns, they ingress, they have a source, they have an origin, and they, at least my interpretation, and they have a target and they have means to traverse time or space to reach. And I found this very operative in the sense to explore this. There's also, if we think of it, it's very direct, or at least directed, because they have a source and they have a target. And if their objective, for example, is to reach somewhere, we have, it's akin to equifinality. So I know it's slide one, but if I'm going to say if mathematics is animated, maybe I can say yes. And is it intelligent? Well, a la William James, I would say, this is on the table. So definitions, I borrowed equifinality from general systems theory, which is reaching a goal by different means. In this case, it can be pathways like developmental, but if the goal is some sort of organization or state that is coherent, or even if far from equilibrium, I feel that this fits. And also, I want to propose a definition for spectral, which can be viewed as encoding environment dependent dissipation and microfield statistics, for example. Or we can see it as exponents and curvature functions in symmetry-informed accounts. Moreover, we can also see it as compact encoders of transport and coupling, which are the same ingredients that shape dissipative structures, linking matter, light, and life. And transport, there are a lot of transport theories, and I'm writing something that is like, do we need another transport theory? Which I think, yes, for this case, yes. For ingression mechanisms, I think we do. Because my suspicion is that even though there is this coupling with cognitive glue, which some of the mechanisms we know, I think there is a partnership with, and this transport may require new mechanics, or at least from our part. Sorry, I drink water. And so one thing I found really interesting is that we can have all these patterns, they are resemblance, or there's some sort of resemblance. And I find really interesting that to have, to propose something to be, for example, equivalent to something else, or to prove, that there is symmetry at play, you need to move, and you need to transform something, and you need to transform something from one thing into another. And well, and I find this, it's not a singular move. It requires other things. It requires something that moves it, or for it to move it, but it already, it's as almost, you cannot have, like, on the bootstrap of things, like how the first thing came to be. I like this very much because it's a constructive act. And I also like this etymological note, for example, on compute, where you have like to reckon or prune together. Prune, I added, because I think it's interesting further along. But then you have symmetric, which is, measure together. And then you have geometric, which is measure space. And so you have a lot of measurements going on, which implies some sort of device, but also reasoning agents, right? To actually be able to measure it. And so I'm not going to present it here, but I did something interesting, which was on this thesis of computational symmetry. And then I threw like a first order logic, or folds more specifically, which is just a semantic way to compute like some sort of logic proof. To do it a la William James, that for you to compute, the symmetry, like you need to be, it is an intelligent act, I guess I said. You're solving a problem, you're reaching a goal, which is to be the same while moving, or to transform yourself, or in transformation, while maintaining this link, to your identity. And so I found this really interesting. So for now, also Platonic space, we can understand it very freely. Personal take, I see it as some sort of like canonic or canonicism, with the respect that from our perspective, it will look like invariant or eternal, which perhaps just means that, these patterns, their origin, they don't have time. For example, they have, another space that does not need time, maybe has all the time, which is something that I like to think of. And so, okay, so reaching the same goal, like in this case of symmetry, it means that you have an observable invariant that stays fixed with turnover. That can be molecular, chemical, thermal, electrical, which is in a sense exactly what symmetry and transport are said to preserve. And then by different means, that can switch along the symmetry related options and still succeed, which is in systems theory notion of equifinality. So again, I was clearly very excited about this, but I think there's something really special here. But okay, transport, what are we, what is a transport? So the patterns they ingress, obviously they need to have a means too, but perhaps this is a message. I mean, I propose this is a message. And this message, more classically, you would have the noise source at the channel. And throughout this project, I've come to understand that perhaps the noise is not at the channel, or the proposal is that to see noise as something that passes through, in this case, or in this context only, that I mean, the noise is the message, which in the case, for example, if you are computing a symmetry, what it is not symmetric when you're computing it, it's the difference between the states. And so this would always be considered noise because it does not make sense, but actually does. It's a organization enforcement mechanism or signal by the difference, which it would be very inexpensive also in a sense. So instead of carrying on the entire structure, you just carry the difference. It would also be structured. But so also important is that if we look at this like message passing perspective, you have feedback, or at least in principle, if one can receive messages, and then I'm going to propose like the polycomputational for now, even though I didn't propose it yet. But there is this transceiving property, which means we can receive a message, but we as a planet, or we as a person, there is a polycomputational architecture at play, and a lot of messages are going up and down, or within the structure and outside the structure, and they're sensing. And so I think the important thing is that there is this notion that there is feedback. And thus, from this perspective, the robust scaling of goals could be the invariant in polycomputers, for which I argue that is the material expression of priors, where the goal is achieved by different instances of forms, and is oriented at exploring space through growth. And unfortunately, I'm not going to have time to show everything I wanted, but this I found really curious, which is there's a lot of discussion within mathematics about the origin of mathematics, and true, and there's this neurophysiological and behavioral study about the reaction of mathematicians to formulas or expressions, and yes, and there is, well, in the study shows that it's not culturally dependent. So even though it activates the same areas that would be responding to, for example, aesthetics or moral judgment, which are said to be, for example, culturally dependent. In this case, when the reaction to, for example, Euler's identity, it does not depend culturally. And so there's this sensation that it's not that it's universal, but it's something that transcends culture. And yes. And so, well, the proposal is that these messages that are spatiotemporal intuitions, they are not constructions of the mind. We construct and we formalize them from our minds. But the first impact, or the reception of the signal, is something external, which I understand it is controversial, but we live in a world in motion. And so we can be very little or an embryo, and we would feel the pulse of being in a nested architecture. There's also the laws of nature, wind, there is circadian rhythms. And so there is a lot of ways where spatial temporal intuition can be transmitted. Sorry, water. I really admire Henri Atlan. I don't know if he will listen to this and ever, but he had a little bit of a problem with information theory, in the sense that he wanted to apply it to biology, like he wanted to relate it to biology, because there was a lot of, for him, the biological information and the way that systems cohered within hierarchies, it needed to conform also with information theory. And a few years ago, when I bumped into his concept of its complexity from noise, and he has a specific definition for complexity. It may not be really important for now, but in what he tries to convey is that there is this sense of novelty. So noise actually brings the novelty. Okay, and so we have a message that is passing, and we have a signal. And we have a polycomputer, which I'm saying for now that is a transceiver. We can also say that is a transductive or a mechanotransductive architecture. And if we ask what is the goal, what are we going to do with this spatial temporal intuition? I would argue that is, in this case, it's bisimulative, in the sense that these messages to explore space actually allow us to do constructions in space and then to explore space. So it's almost as if it's an intelligent echo going into intelligent echoes. Mm. And okay, I don't know if you agree with this, Mike and Anel, but for me, a polycomputer is a multi-scale competency architecture. Okay, and so itself, and for all its instances, it must compute these equivalent states to persist as a pattern that is recognizable amidst turnover. So it means that everything moves. And there must, I guess, our big problem here is how do all the small parts and all the big part has a canonic reference of what it ought to be while everything is moving. Because we tend to look at it at very like static, but in fact, I feel that this is very complicated. For example, you can have an olive tree, a Portuguese olive tree, and you can have like 1,000 of them, and just in Portugal, and then you will have 1,000 everywhere else. But would putting them all together bring us the canon of an olive tree? And how is this canon of an olive tree is connected to, for example, the idea of a tree? And I know we're talking about like very abstract and then very concrete, which is, for example, in the case of tissue regeneration, even though we don't really know the order of what came first, if it's abstract or concrete for now. But I do feel that the problem is pretty much the same. But there is an invariant for us, which is this motility of a pattern. And I also argue that this is a geometric effect, geometric in the sense that we are measuring space. And officially or classically, when a curvature parameterize the admissible transports to make it still the same, there is a selection of the invariance that defines this goal. And now we start to connect this with the noise. So while the polycomputation architectures may not have, for example, the canon, something akin to, for example, an ancient mechanism like bioelectricity may be carrying that information for us. And since the beginning of time, we have a way, or polycomputational architectures have a way to make sense of this noise. And for example, like forms are maintained through admissible motions that reckon together and measure together. I also really like this idea because they're polycomputational architectures. And so one proposes that they are reckoning together, they're measuring together internal states and external states. And these ought to have equivalent classes. Mm-hmm. And I have a lot written on ingressions. But I think one idea that is fun is to think that one type of ingression can be, for example, this type of like Nflex. First I had like Nspire, but perhaps not as optimal. But then you have Inform, because we do have patterns that make forms, and then we do have patterns that perhaps as thoughts, you know, they are transient. And here, this also became rather complicated, but I guess the scope is just to convey that all, and I like to say the laws of nature, all the laws of nature, they have, or physics, there is a geometric interpretation allowed for all of them. Thus, my conclusion that nature has geometric interpretation. And because of this, thermodynamics has geometric interpretation. And for us, for example, to compute or to formalize the thermodynamic process in a dissipative structure that is far from equilibrium may be really hard in terms of computationally and in terms of amount of formalization. But if you look at it geometrically, it becomes a little simpler. This is also my proposal for where are these canons? So the canons or this Platonic world cannot be very far. Or if it is, which is a proposal for after, if it's very far away, the way that a polycomputational architecture can access that canon or receives that canon, it's very present, or it's very precise in time. And for each, the proposal is a bit in the air, but it's this relationship with time. So we do have within the logic of irreversibility, even though our laws allow for reversal in time symmetry terms, perhaps what we're talking about is something I've been trying to consider as, it's not an imaginary part of physics, but it's just something that can be done instantaneously or feel that is instantaneously. I don't know if you can see my cursor. Okay, but the idea is that through what we've seen, or what I've seen with disattunement or entrainment mechanisms for message passing and for mathematical intuition, or for this like strike of mathematical intuition, there are these moments of profound meditation, or you have a problem to complete, or you have a construction that does not make sense, so you have a lot of rules, and you sit with it, you want to resolve it, and this creates this attunement mechanism. Every attunement signature for what I've computed so far, it is a complex construction, but these attunement signatures have an index, and this index, it is fairly well expressed mathematically. It does not have, for now, anything like a physics interpretation directly. But the mechanism would look a little bit like this. So you would tune, these signatures they are mapped to an index, and what you get, it's like a request, and what you get back is exactly what you asked for. So it's signature dependent. It is not context dependent, but it's scale appropriate. I guess this is. And so one of the very interesting patterns, or these canonical forms, would be, I think it was like the first one. I was working on it, mathematics, before. And there are a lot of models that are fairly successful at modeling, for example, philostaxis or spiromonostici, which are patterns that are, it's really hard to model from a physics perspective what is happening, but mathematically it's fairly easy, specifically philostaxis. And there are two models now, or two newer models, and one of them had this inductive field that would work along inhibitory pathways or fields, if you want, because it creates waves and there's an equivalent, so you can say it's a field. And I thought it really interesting to try to make it physics-based, based on pneumatics. But of course, there is a part that one have to resort into a construction that does not have a representation. But is this working? Yeah. I don't know if you can see it, that it's moving.
We can.
Good. And so there's a lot of, I ran a lot of different scripts to try to approximate, and there's a lot of trial and error, of course, in this process. And there's also a lot of, let's find like the transport problem, right? Like, or the transport phenomena. You can go like on Fick's law or Fourier's law, this is not the same. And then you go and you say, no, there is a similarity. And I'm going to pick the similarity, and I'm going to see if I can bundle these things together, and if they reckon together, if there is a symmetry. So I really do believe that, for example, in the transport phenomena, that's what it was accomplished. It was like, okay, this, I mean, this can be a grand generalization. Perhaps it does not have a lot of utility, for like, building a building or a bridge. But I do feel that these things are really important. So this is what I've done here. Again, the construction is fairly complicated. But then, you have almost, I guess what is mind-boggling is to imagine that there is some sort of parallel, there is like a correspondence between whatever it is that it is our world and hypothetically, a platonic world, that there is like this communication, and that this communication is animated. Sorry, it's a bit slow. And so when in this model they did like it was an inductive field and the inhibitory field, and in principle you would get like this Fourier bezel, and at the zeros you would have, they didn't compute it as a signal, but I decided to make the three constructors. So you would have the 0 one, it's like beyond the inductive, and then you have the inductive, and then you have the inhibitory. And so it's almost as if there's like our polycomputational architectures are capable of doing frequency mixing, which I think it's fairly more easy than doing mathematical formalizations and proofs and the way that we do it. This is a computational way that is slightly simpler. Okay, just checking the time. And so, okay, I'm going to be really vague, but I think today I had a little bit of a breakthrough, and I'm glad we're going to talk soon, because I feel that, experimentally, I don't think there will be any harm. But if it is right, I think it could do a lot of good, and it's really cool. So we have, okay, if in this context the following is true, what we formalize mathematically, there are hints for pattern completion as message passing intuitions, and thus the following propositions that a direct communication protocol could be seen as a Turing test, because morphogenetic processes, for example, they look very much like pattern completion problems. And then you also have like pattern theory. So patterns is something that is fairly ubiquitous, and they're a little bit like puzzles. And I mean, if intelligence is going to be intelligence by different means, and is driven by problem solving, I feel that if in this case this is true, there is this direct communication avenue, for which we are being proposed consequently to, solve problems, which is a test. And then for this reason, there's another interpretation, which is this could also be like a transdiagnosis situation by bias simulation. So the other day, a friend of mine sent me the most beautiful letter with this super intelligent alien. This is a statistic problem, but there's a super intelligent alien called Omega, and the idea was to try to see if we could, reason at the level of a super intelligent rational agent, and yeah, and one of the comments was that the only way to do it, one way or the other, would be to simulate the other to the best of our abilities. But in either case, I feel that given the message passing paradigm and the feedback, we can use it to reciprocate. And again, if in this context the following is true, the third realm of Freud's, if it exists, I would pose that it's of a spectral quality. And in this case, polycomputers are spectral samplers. Spectral signatures appropriate at scale, but scale invariant, such as scalars, can be mapped to spectral indexes, such as addresses to canonical forms in the Platonic world. The postulate is that certain mathematical objects are implemented beyond formalism and are rich, and they can fly, which is, here this is really an analogy, but it's also a funny reference. And also that they can be in different places at the same time, also because of the time constraint. Okay, and if in this context the following is true, we see that polycomputers are spectral samplers, and so we are also polycomputers that can sample other polycomputational architectures. And thus we can induce specific spectral states for desired developmental outcomes, but other things. And the spectral states act as a request, and one gets a reciprocal response. And if in this context the following is true, given the scale-free paradigm of polycomputational architecture, scales are connected by invariants, which are constants, and their scalars, which are indexes. And the indexes can be generalized into two main modalities, such as proposal, stability, that would add some sort of growth and emergent at a new scale, and instability, a new order of dissipation. And okay, I also predict that what we are onto is really close, but it will not explain the universe. And the rules are really simple to grasp, yet extremely cumbersome, extensively, and laborious to compute. I also think that there's like a lot of findings here, right here, and this is really exciting. And from my experience so far, is that they require that one looks for a billion affinities in nature and a little bit of courage, because they are not found in literature directly. I mean, related. And they are counterintuitive after intuition and correspondingly proportional and reciprocal. The benefits I feel of this approach is that it leaves a lot of freedom and responsibility, because it is up to us to, for example, complete patterns or reciprocate, but also from the perspective that we know that higher patterns in terms of organization, like for example, climate, governments, all these things, some we create and some we do not create, but we know that the hierarchy ends up making the lower one on subsume. And so I feel that the responsibility here is that some patterns they imprint or they ingress, and we choose to make mathematical constructions, for example, with them. But there are others that through these mathematical constructions, then we build something else and it becomes a lot bigger. And then we kind of lose control. And I feel that the benefit of looking at it in this context is that, yeah, we have freedom to choose what we want to construct and what we want to formalize and we would want to give attention to, and also responsibility in how we do it. And so I leave you with this beautiful thought of Einstein, which completely I agree that in the sense, and in the sense only, I belong to the rank of a devoutly religious man. And I have a lot of really, the writings have become truly extant, and thus, and also the experiments. If you find that this resonated with you out there in the world of the internet, please contact me. I would love to hear from you. And for now, this is all I have. Thank you so much for listening.